Hello everyone, welcome to Triaright, the new era of learning. This is Pack 365 in Module 8. Today we're going to learn about decision tree in machine learning. Let's begin the topic.
What is the use of decision tree and how it's work? We discuss in this today's section. Okay. Now let's watch. A decision tree is a supervised learning algorithm. Obviously, use it for both classification and regression tasks. Okay. It has hierarchical trees structure which consist of a root nodes, branches, internal nodes, and leaf nodes. Okay. It works like a flowchart, helps to make decision tree step by step. Okay. uh Decision tree is nothing but we call as distance decision tree structured based. Okay, any we have a random data and we divide the data and we arrange the data into structured manner with decision trees. Okay, so here decision tree is a powerful supervised learning algorithm. Okay, you for what it uses for classification and regression tasks. Okay, it works by splitting the data into branches, into multiple branches. It divides the data based on the future's value, creating a tree-like structure where decision tree are made at each node. Okay, in it we have a root node, internal node, leaf node, and branches. Okay, for root node, mainly root node we will consider. So from the root node is nothing but parent node. Okay, the starting point where the first decision is made, from the first decision where the started. Okay, like see here, a sample example, decision tree, a flowchart like model use the classification and regression. It split data based on the future to make prediction it looks like. So here the root node. Okay, it is a main node. So here from here we are starting the decision. Okay. After that it converts into internal nodes. These are the decision nodes, nothing but is an internal nodes. Internal nodes nothing but decision points where data split. Okay, here from the data were split into other parts. First, this is decision starting main root. Here the decision will start, and after that here internal the data will split further other, so further other leaf nodes. Okay, leaf nodes is nothing but the final output of classification. Okay, in this we are seeing this the branches is nothing but it is based on the condition showcase the output. Okay, now let us watch an example of decision tree. Right. See, the model checks the conditions like age and gender to split users into group. Each group leaf node get prediction score based on user performance. Okay, or computer for computer games. So let us see what our input age, gender, occupation. Okay, so prediction score. Okay, now does a person like computer games or but we have a specific age, gender peoples here. So in that we want to identify the how many are like video games, computer games. Okay, at age 15. Here we can decision make the decision like here. First we consider age. Age 15 we have above from here and below age here. So in this we have other category in after the into internal load. In internal we consider male and female like gender, male and female. Okay, occupation is nothing but plus one. This is a plus uh, 2 0.1 minus 1. Okay, let us get a real time example. let us show I Let us show the real time example. Wait, so I have a data called XYZ companies. So I have a data XYZ. Okay, so nothing but this is a company. Actually this is a company. Okay, so this is my company. Okay, in my company, so I have a Google, ABC Pharma, Facebook. A example, let us take a example base I am explaining you. So from here I have companies, three companies, and in the companies we have jobs called sales executive, sales business manager, computer programmer, sales executive, business manager. So we have three types of jobs, three types of companies, three types of jobs. After that, based on the job requirement, degree, bachelor's, masters, right? From the based on the salary, who had a more than 1 lakh. Okay, for business managers, they are computer programmers. In some of the companies has above 1 lakh. Okay, based on this data, we create a structured. diagram. Okay. So we have all this data, right? Company jobs we are discussed, right? So from how many companies have three jobs, three degree, three salary. Okay. From this data, we create a the decision making tree. Okay. So let's uh, let's create a table. Let's create a rectangle. First, we create a table, right? First, we want to make main decision, right? Main decision. Okay. From here, we want to make a main decision, right? What decision made? What the decision made? I have a company, right? So from this, I have made a company. Okay. After that, the company, we want to consider a line. Here we get three statements, right? What are these? One is job, and another is degree, and another is more than 1 lakh salary. So first we didn't enter into the 1 lakh salary. First we analysis the job. What are the job? Google. First you are discussing about the company, right? It is the main decision. Decision starts from the company. Further, what are the companies? Google, ABC Pharma, Facebook. Okay. Three companies we have. Let's take three companies. Okay. Let's take three companies. Okay. From this, let's take the three companies details. It is the internal notes. Okay. So I considering G has Google, and here ABC as ABC Pharma, and here I considering what are the last tip Facebook, right? So I consider here Facebook. Okay. I simply wrote FB. Okay. This is the three companies which we have. Okay. So this is our company. From this Google, how much we had for Google, how many we have jobs? From Google, we have jobs sales executive, business manager, and computer programmer, right? So from this, both are having jobs. Okay. So directly I assign direct the job, direct, direct branches to branches. I directly enter the leave. So for sales executive, we enter SC. For business manager, BM, and computer program CP. Okay. Now take data again. From here we have three. From Google, we are having three roles, right? From ABC Pharma, we are having three roles. Okay. So only taking the example, not overall. Okay. From Google, this structure we want to make. Okay. For this Google, we have a sales executive, right? So what are the sales executive? What are the sales executive? We have SC, we have SC, and another one we have CP or no business manager. Right? What's another data? What we have? Product manager. Okay, business manager. Right? BM. Okay. Okay. For this we have business manager. For this we have computer programmer. Right? We have three roles here. SC, BM, CP. Right? We have three roles. For this role, we are considering here uh, SC. From SC, how many, what can final output as a degree? how many degree bachelors, how many masters. For SC they have in Google two members, two of the bachelor, one is master, one is bachelor. Like this we want to assign. So for this sales executive has one bachelor, and another business manager has one bachelor, and computer program also one bachelor, bachelor's master, right? Two data we are here having. So from this how many sales? So simply we can create a tree like simply we can create a tree like this. So from here I had two datas for both water. One is bachelor, one is masters. So it's the final leaf code. So indeed the final leaf is the final leaf when we are going the final leaf. How many are more than 1 lakh? So in Google we have any output? No, only one person has business manager and one business managers are having high. Oh, one is master, one is bachelor, right? They are having more than 1 lakh salaries. In what for which company they are from Google, from business manager, bachelors and masters. Okay, right? From Google, from company Google, business manager, right? From here we want to consider, right? No one sales executive, there are no one, right? So I'm taking like this the extra data. So here I have data. So same bachelor's, masters, right? From this data, we consider one has 100K and another also having 100K, right? So this like we can design a decision tree structure based data. So according to this, for we moving coding. So this is the way you have to design your making to first start from the making to make the decision, and after that convert transform into the internal node, then passes to the leaf nodes and sub internal nodes, leaf nodes, the final child node. Okay, final output. So this like we have to divide the flow chart into decision making. Okay, now so for this we want to take the code like, so this is my Jupyter notebook. So firstly we want to open Jupyter notebook, cmd command from Jupyter notebook. We can install pip install Jupyter notebook in command. Okay, is the best way to analyze the project. Okay, Jupyter notebook, enter command. Okay, here we want to run the code. Now we get the home page. Okay, new data. I'm creating new data. From this my title gonna decision making DCM decision making tree. So from here we all know I have seen the data sets of salary. So from this salary I'm importing data from here. Okay. So from this first we all need to know import the pandas as PD. After that we want to read the file where we are mentioned. So I already copied my path. No, I didn't copy my path. So where the data is located. So this is my data. So I'm copying the path. So that moving here. Take full path or you directly give as a name. But to my when I am considering my path, so I have to assign the full. Okay. Now define a variable called df. Okay. We define the data. Now print it. In Jupyter we didn't for printing statement we didn't enter print or show like that. Okay. We just directly assign the variable and it automatically prints the statement. Now see, this is our data, right? Google job drive. So from this data, we need any salary. Here we didn't need about a salary. Okay. So simply drop the salary is unnecessary column. So like for that, I'm like inputs. I'm taking a variable called inputs. From inputs, I am dropping d or drop assign the correct name or the data will decline. So from salary data, I'm removing salary. Okay, from column salary more than who has a 1 lakh. Okay, from which axis? From axis column. Okay, okay, now done, close it. Now print inputs. Now see, our salary column has removed successfully. Now the removed column we need to target. Okay, so simply I want to saying that our machine language, machine understandable language is what high level language. Okay, machine only understands the value of 0 and 1. Okay, machine doesn't understand the string values. If you give in my name is Raju, it doesn't consider your name is Raju. If the my name is Raju converts into binary string format, if the 0 1 1 consider, then the machine will take the output. It doesn't take the hash directly as a numeric. So it understands the numeric decimals, right? Not an a string based alphabets. So we want to assign the value into numerics for a better understanding for machine. Okay. Now let us we want to make a target for test. Okay, I want make target which I'm making target for the column which I drop. So I'm taking my previous column has data salary. There, this is the column I had dropped, right? From this column I creating a target. Okay, my target is created C010. This is my target, right? From this target, we want to import the pre-processing label encounter. So we want to change, we are creating a duplicate. We didn't need, we have a C, we have a Google, we have a job, degree. Those all statement is we are run into the code. The machine doesn't exist. Sorry, machine doesn't understand the existed values. Okay. For that, we want to change the Google into a binary, jobs into a binary data, degree into binary data. For that, we use label encounters. So from that here, Google, I think Google and we have three companies from the index based on index value 0, 1, 2. Yeah, either Google consider one or two, other pharmacy consider one or two. For based on depends on the variable, it converts the into numeric value for this all data. Then the machine can easily understand. Okay. Okay. For this, I am from sklearn we had from sklearn we have a function called pro processing. Sorry, pre-processing. Pre-processing. We want to import label encoder. Okay, from this label encoder I'm creating a company and I'm creating a variable. Okay, nothing, I'm creating a new column. Okay, from this column I'm label encounter, sorry, label encoder. Okay, from this I'm creating both three. I'm creating label for job and for degree. Okay, same code. Okay, now after that I'm converting into input for this I have created. Okay, now assign value directly, so the system will take the outputs. Now here we want to take inputs. Here we want to assign inputs. From inputs we have taken company and right. What the error? Label encounter cannot import name label encounter. So here Timothy, you are considering space, so it takes that like that. So from here inputs. From inputs we are considering company of n, and assign this equal to le company dot fit. It is a method fit transformation. We're transforming our data here from string to decimal. Input from input company. Okay, from this you are converting, right? So same for tree. Okay, from company and from job and for degree. Same like company. So here also we want to change job degree fit transformation for input for same which column you are replacing job, and here fit transformation for degree. Okay, we all considered the outputs. Now simply print the input. Let's see what will happen. Label encounter object not fit dot and operate, but what man? Layer company label code was running successfully. So here we have the syntax error. So for that, no see, uh, here we have duplicate of company and numerical of job and numerical of degree, right? We have a numerical form. Okay. After that, we are getting the new all the numeric value for here. Let us watch. The ABC format takes 0. Okay. From index we have three data. Okay. For I'm talking about company. In company we have three basic data: the Google, ABC format, and Facebook. So let us read with index base 0, 1, 2. Okay. For Google, it's considering 2, and for ABC format, considering as 0. From Facebook, it assign 1. Okay. Same as for job. Okay. For job sales executive as 2. We have how many kinds? Same here also 3. Sales executive, business, and computer programmer. Right. For this also is assigned. For business manager, it assigns 0. For computer program 1. For sales executive 2. So degree, how many are bachelor's, master? 2. So it considers 0, 1, 0, 1, 0, 1, right? Where the master's located in this place, it once, and where the bachelor's, it gets 0. Okay. Now we get the numerical data. Now we need this string-based data. We need data. So no, no. So drop the data. Inputs drop for which you are dropping company. I'm dropping company. After that, job. Next degree, right? I'm dropping the column. I didn't need this column right now. Okay, now completed. From where axis? From axis columns, right? Okay, close it. Now print inputs. Here we same input and input we are considering same here. So for that we want to assign called data. We assign data. Okay, we assign now print data. Now see, successfully removing data. We have the main data. From here, we are preparing a model. Okay, from here we're preparing a model called sklearn. Here, import tree. Okay, here we're importing tree. We are for model we are creating tree dog decision tree classifier. Okay, from here model dot fit. Okay, for what for my data and for my okay, here for data and for my targets, right? I want to run this code. Huh? What happening to my laptop? Okay, model is not defined. For this little bit space, also it getting a mistake from here. Okay, spelling mistake right here. Model. Still it. Okay, what happened to my laptop? It's a little bit issue with my laptop. Okay, see here our data addition tree is created. So from this we want to take the score, like model dot score, from what score you are taking data and target score you are counting. So it's getting the score. 1.0 means 100%. Our decision tree is prepared and it's get the model is imported and the model is created with 100% accuracy. Okay, is our model score. 1.0 is nothing but is not less. In the numerical constant, we are calculating the number from 0, 1 means 10%. From 0, 0, 1 means 0.01 means 1%. 0.01 means 0.1 means nothing but 10%. 0.5 means 50%. For 0.05 means there are 5%. Okay, right? So here we get 1.0. So it's nothing. It is a big value. It is a 100% success rate. Okay, this is like how we can create. So now see, let's classification that was easy. So here uh, pandas, see, we import the data set. After that we make a target for salaries, and after that we remove salary and we make target, and after that we encoded for label data to numeric values. So we get the assigned numeric values in binary sets, binary data. After that we removing the data, and after that original data means do job and degree. Okay, and from we take the converted data. From that we are created a model. Okay, now the machine can easily understand. It creates accuracy of 100% decision making tree. Okay, hope you guys all of you understand about this. Thank you.